Okay, let me take you through this practice quiz. The first question, this form of our rational function, we should instantly be able to tell our vertical guideline and our horizontal guideline. So the whole key to this problem is I see an x plus 2. I'm going to know right away that x equals -2 is where I'm going to have a vertical guideline. So I'm going to draw a vertical guideline. And when you state your domain, so when I do my domain, we can use any number except for a -2. Okay, and when we type this in our calculator, I'll show you that we'll have an error at -2 because if x is -2, you're going to end up dividing by 0. So that's where I get a vertical guideline. It's a shift to the left 2. This number right here is our shift down. It is where we're going to have a horizontal guideline. So y equals -2 is our horizontal guideline. It's also my range. So all numbers except for a -2 is my range. So then I go to my calculator, I go to the y equals screen. Two ways for this one, I'll use parentheses. So I'll do 2 parentheses or divide, then parentheses, x plus 2, close the parentheses, and then -2. I can see what the graph looks like. We're going to have some dots down here, and we're going to have points in this corner. So I just need to go to my table and gather a couple points. So when I go to my table, like I said, I can see that there's an error at -2. I expected that because you can't divide by 0. So I'm going to plot -3, -4. So -3 down. 4 is right here. And I'll also do -4, -3. Okay, 2 dots, but I can use my guidelines and you always get closer. So you get closer to -2 on this side, your y values are getting smaller and smaller. So on the other side of my error, I see -1, 0, and I see 0, -1. Again, 2 dots, all I need, and there's my curve. Okay, and I am finished. That's all I'm going to need to see on your quiz. So again, I may change some numbers around, but use the calculator correctly and use your guidelines to help you. So for number 2, I'm going to make you rewrite this. Okay, so right now we're not in the same form as number 1, but if we use long division, we'll get the same form. So I have it already set up here on the practice. So x into 3x is a 3. So I put a 3 up top, and now I need to multiply. 3 times x is 3x, and 3 times 4 is a 12. Draw my line, and I'll use a different color, and I'm changing these to its opposite. So then I end up getting a remainder of -6. So the remainder goes over the divisor, which you divided by. So really what this is equal to is -6 up top. So it's a reflection. It's also a vertical stretch. But I have x plus 4 in the bottom, and now I have a plus 3. Okay, so looking at the denominator, I know it's going to be a shift to the left 4. So I'm going to have a vertical guideline at -4. Since it's up 3, I'm going to have a horizontal guideline at 3. Okay, so my vertical guideline, let's go down here, is x equals -4. And as soon as I do that, I'm going to be able to state the domain. Any number except -4. When we use our calculator, we'll see an error at -4. For the outcome, we're going to have all outcomes except for a 4. So y equals 4 was my guideline, and then my range, all reals except, oh, what did I say? Sorry. It's a 3. It's a 3. I went up 3. So my guideline I already drew is at +3 because it's up 3, not 4. And it's everything except, why did I not spell except right? Except a +3. Okay. So I have my guidelines already there. And so now I'm just going to pick up my calculator, and let me just stress this with you. I would type in the original just in case you messed up, with your long division. You can type the original provided you have parentheses around the top and parentheses around your denominator. Okay. So the graph is going to look like this. We're going to be in this corner and down here. Okay. When I go to my table, I'm going to see an error at -4. Okay. So right there's my error. And I'm going to plot, let's do -7 up 5, 1, 2, 3, 4, 5. And I'm also going to do -6, 6, 1, 2, 3, 4, 5, 6. And I'm just going to follow my guidelines. Should go through that dot. Okay. And remember that extends up. I'm always going to get closer to my guidelines, never touch them. Okay. And this draw an arrow just to show you that it's always going to get closer to that horizontal guideline. This will always get closer to the vertical guideline. And so then on the other side, I can plot -3 and then down 3. 1, 2, 3. There's a dot. And I'll do -2, 0. Okay. If you want more dots, you certainly could plot more dots. So like -1, 1. So I'll do 3 dots on this side. But that's what's going to happen. I'm going to get closer and closer to my guidelines without ever touching your guidelines. Okay? Does that make sense? I'm hoping it makes perfect sense for you. So you're going to have 2 graphs on your quiz, very similar to these. Okay? Then the next part, we're going to practice adding and subtracting. Okay? So let's go through that part, and then we'll end with the multiplication. So a problem like number 3, I need you to realize I already have a common denominator. So since I have a common denominator, I'm allowed to combine what's up top right away. I can add. So we're simply going to add 9u plus u is 10u. So this and this are alike. And then my v's I can combine, and I'm going to get a positive 4v. Okay. So now technically this can be reduced. Since everything's even, I want you to be aware that I could factor out a 2 up top. So if I factor out a 2, I have 5u plus 2v and then 64u squared. Now I can reduce this 2 over 64. It'll make the 64 a 32. So really the simplest answer I can put is 5u plus 2v over a 32u squared. Okay. Now you're finished. Do not be tempted to cross out a u in this u because this u is a term. Okay. Terms are separated by plus or minus signs. You can only cancel out factors. So this is in simplest form. I will let you know if you need to simplify on your test. Okay. So number 4, good news is I have the same denominator. That saves us so much time. But since it's a subtraction problem, change it to an addition and change these to their opposites. So now watch what happens. Now I can combine these. My x's disappear and I get a 6 up top. So I'm just going to be left with a 6 up top. And my dot, I don't even have to factor this. I can leave it in that form. They're the same, so I just have to combine my numerator. Okay, so that's done. We are finished with number 4. Okay, this one, we don't have a common denominator, so we need to look at factors. This first fraction, I don't do anything with. I can't do anything with 2b. It's simply 2b. But then I'm going to change this to a plus -5b, and I'm going to factor out a 2b in the bottom. So when I factor out a 2b from these 2 terms, I'm going to be left with a b plus 4. Okay. So then I'm hoping you're going to see then your LCD, the least common denominator, we already have the 2b in common. Both fractions contains a 2b, but the first fraction's missing a b plus 4. So I'm going to squeeze in a b plus 4 here. Whatever you do to the bottom, do to the top, and make sure you're multiplying. You can't just add something. I can't just add a 4 to a 2b. You have to be multiplying. But the good news is both denominators are now the same. So here I'm going to distribute the 3. I'm going to have 3b plus 12. And I'll write this as a separate fraction just to show this. And then it's going to be plus negative 5b over 2b, b plus 4. So the only thing I can do yet, I can combine this now into one fraction because both denominators are the same. And if I have 3b plus negative 5b, it's negative 2b and then plus 12. Okay. And what can happen there, I can actually try to reduce it. So what happens, I can factor out a 2. Okay. So I can factor out a 2. And if I factor out a 2, I'm going to have a negative b plus 6. And then 2b and b plus 4 in the bottom, these 2's can be crossed out. Okay, so your final answer is going to be a negative b plus 6, or you could say 6 minus b, it's the same thing, all over a b times b plus 4. There's my answer. Okay, it's in simplest form. Okay, the next one, again, plus and a minus. So both denominators can't be factored. So this is a factor and 2k is a factor. So my LCD must contain a 2k and a k minus 5. So this fraction is missing the 2k. This fraction is missing the k minus 5. So whatever you do to the bottom, you must do to the top. So I'm going to multiply, and then this is going to be multiplied by x minus 5. Okay, so up top, I'm going to write this as one fraction because both denominators, that's a k, not an x. So k minus 5. Okay, so now up top, I have 2k times 6k, which is 12k squared. And then I'm going to distribute this. It's going to be a negative 6k squared plus 30k. Okay, all I did was distribute. And then I'm going to clean the top up, and then we're done. So when I clean the top, these become 6k squared and then a 30k. Okay, now that can be reduced once again, only because the top, I need you to realize that these are both even, so I can factor out a 2k from the top two terms. So I'm going to put a 2k up top, and I'm going to have a 3k plus 15 up top. On the bottom, I write my factors, and you're going to see that cancels out. And actually, I missed it. I could have factored out a 6. 6 goes into both. So my GCF would have been a 6k, not a 2k, but I can fix it here. I'm going to factor out a 3, and I'm going to end up with a k minus 5. Okay, so either answer, technically this is fine. So I could have, so by factoring out a 3, it doesn't really change this problem. So either answer, you can have 3k plus 15 over a k minus 5, or you could write it as the factors. It's still saying the same problem. So this problem is finished. Okay, a couple more. And again, you won't have this many problems on your quiz. Okay, so just be aware, though, I want to give you plenty of examples. So for number 7, I'm going to factor out a 6n. So 2n minus 1 is a factor. Over here, I'm going to have just a 3n minus 2. Okay, so now, a little bit harder because there's nothing in common. Okay, there's nothing that we have when I factor that's going to be the same factor. So my LCD must contain a 6n, it must contain a 2n minus 1, and it must contain a 3n minus 2. So all three factors must be part. So this first, I'll use a different color so you can see it. This first fraction is missing the 3n minus 2. So I'm going to put it in the bottom, and I'm going to put it up top. This is missing the 6n and 2n minus 1. So 6n and 2n minus 1. But the good news is now each fraction, I see a 6n here, I see it here. I see the 2n minus 1 here, I see it in another fraction, and I see that we have the 3n squared. So we have a common denominator. We still have some work to do though. So this is our common denominator, but we're going to clean up the top. And it's going to take a couple moves to clean up the top. So just be aware, this is a tough question. So if you don't fully understand this, you still should be fine for the quiz. So up top, I'm going to distribute a 2n. So we have 6n squared minus 4n. Okay, that's this distributed. Now, I want you to treat this as a 36n, okay, because I can take 6 times 6n, which is 36n, and I'm going to distribute that. So when I distribute, I'm going to get a 72, because 36 times 2 is 72, n squared, and then I'm going to have a minus 36n. Okay. These are like terms, so I'm going to end up with 6n squared plus 72n squared. That's going to be a 78n squared. Okay. And then this is going to be a minus 40n. All over your 6n, 2n minus 1, 3n minus 2. Okay. Now, the last thing we can do is this can be reduced a little bit. Okay. So what happens is we have a like factor. Okay. We have a GCF. And what we can do is we can factor out a 2n. So I need you to realize 2 fits into 78, 2 fits into 40. So I'm going to put a 2n on the outside. Half of 78 is going to be a 39. So I have 39n minus 20. Okay. You say, where's that other? If you distribute, you're back to the original numerator. In the bottom, it's already factored. And all we can do is we can reduce this 2 over 6 is going to be a 1/3, and the n's cancel out. Okay, so final answer. When all said and done, this is 39n minus 20. On the bottom, we have a 3n, 2n minus 1, 3n minus 2. Okay, not an easy problem. Okay, but that is your answer. That's all you have to do. And like I said, I'll let you know if you have to reduce. Okay, so number 8, I expect you to be able to do a problem like number 8. So with number 8, it's a subtraction problem. So I told you add the opposites. Okay, and really all we can do, the first fraction, I'll write it here, we can't factor. Okay, it's just 5 over x minus 5. But this denominator of the second fraction, we can factor out of 5. Okay, and that's going to allow us to see that we already have an x minus 5 in common. Both denominators have the x minus 5. So all I need, so the least common denominator is going to be a 5 and an x minus 5. So this one should be very easy to do. I need to put a 5 in the bottom of the first fraction and put a 5 up top. So then 5 times 5 is 25 plus negative x plus 4 all over my common denominator. And then I can simplify the numerator by taking the 25 and 4 and get 29. And we are done. Okay, so expect a problem like that that doesn't take that many moves to get your answer. Okay, so then one more, and then we switch to multiplying and dividing, which has always been easier for most students. So number 9, this is going to require that we factor the denominator. So this one should be pretty easy to factor. It's x plus 2, x plus 3. Okay, weighs against 6 to add up to a 5, 2 and 3. This I'm going to change to a plus, minus, plus. So really we have plus -5 plus, excuse me, negative x plus 5, and I'm going to factor out a 3x. So when we factor out a 3x, I have that. Okay, so here's what your LCD is. LCD, every factor must be used. I don't see a 3x in common. So we're going to need both denominators to contain a 3x. Both denominators, now we do have this in common, so that's good. An x plus 3 is already in common, but I will need both fractions to also have an x plus 2. Okay, so first fraction, all we're missing is the 3x. Okay, so we can put a 3x, and whatever you do to the bottom, do to the top. Okay, this has the 3x, it has the x plus 3, but it doesn't have the x plus 2. So I'm going to put it on the bottom, and I'm going to put it on the top. And now we're going to simplify. One big fraction, both fractions contains the same factors. Okay, so up top we have a 6x. Over here we're going to have negative x times x, which is negative x squared. My outers is a negative 2x. I'll write that off to the side. So I'll do this in my head. So a negative 2x, and then inside is a 5x. Together, it's a 3x. Okay, and 5 times 2 is 10. The last thing we can do is combine like things. So it's going to be a negative x squared plus 9x plus 10 all over my common denominator. Okay, yeah, may not think that looks nice, but it's simplified. Okay, there's nothing else we can do to it. Okay, so force yourself to understand what we're doing in order to get a common denominator. Okay, the rest of this is multiplying and dividing, and multiplying and dividing has always been easier when it comes to fractions. So back in elementary, it was easier to multiply and divide than add and subtract. So it really comes down to factors that we need to be good at factoring. So this numerator is 2 sets of parentheses, x and x. It's plus 7 plus 7. Ways of getting 49 to add up to 14. There's my factors. This goes in the bottom and it stays together. There's nothing I can do with x plus 3. It's a division problem, so I'm going to multiply by the reciprocal. I'm going to end up putting this in the bottom. So I'm going to factor the numerator, but I'm going to put it in the denominator. This time it's x plus 7 and an x plus 2. Okay, I needed to get 14 to add up to 9. I have to use a 7 and 2. The last piece that needs to be factored is the denominator that goes to the top. So x plus 2, x plus 3. Okay, everything is factored. Now I cross out what's in common. It has to be between top and bottom. So this x plus 7, I can wipe out the x plus 7 in the bottom. This x plus 2 will wipe out the x plus 2 up top. This x plus 3 will wipe out the x plus 3 in the bottom, leaving us with just x plus 7. Okay, we are finished. And I'm not going to make you say, hey, x can't be -2, x can't be -7, x can't be -3. But just be aware that there would be some exceptions that you wouldn't be allowed to plug in for x, some values that you're not allowed to plug in. But that's simplified to an x plus 7. Okay, I'm going to hopefully have lots of students that can do that correctly on a test. For this one, it's a multiplication, so we're not flipping anything, but I am going to factor out my GCF. 8 fits into both an 8 and a 56, and we have an x in common. So I'm going to factor out an 8x, which leaves me with x minus 7. Okay. And then in the bottom, it's an easy, hopefully it's easy for everybody. It's a difference of perfect squares. The square root of 16 is a 4. So I'm going to have a positive 4 and a negative 4. If you multiply it, you're back to x squared minus 16. This top, ways of getting negative 20. So it's negative, so it must be a plus and a minus. 5 times 4, and in this case, I need my 5 to be negative. 4 needs to be positive, so it adds up to a negative x. So I did that correctly. And the last one is going to be x minus and another x minus. Because I need ways again 35 to add up to a negative 12. Well, 7 times 5. Okay, so again, it's the key to this is factor correctly. And now look for like things between the top and bottom. X minus 7 gets wiped out by the x minus 7 in the bottom. This x minus 5 gets wiped out. The x plus 4 gets wiped out, which leaves us with an 8x and an x minus 4. And you are done. Do not be tempted to say, Mr. Ray, an 8 over 4, doesn't that become a 2? You can't cancel out terms. Terms are separated by plus or minus signs. This stays together, okay? So 8x over 4x minus 1, that's the answer, okay? Almost finished. So with this one, 9 is up top. I factor out a 7, p plus 4, okay? This, I can factor out a 3. I only have a 3 that goes into 9 and a 12. So I'm going to put a 3 on the outside, 3p minus 4 inside. And then this last part, a 9 can fit in. So I can factor out a 9, 3p minus 4. Hey, look how convenient that was. So now we have all factors, and I can cross out the 9 because I have 9 as a factor up top and on the bottom. The 3p minus 4 wipes out. And so I am left with a 3 is remaining up top. Nothing wiped out that 3 there. And 7 is still on the bottom and p plus 4. And I am done. Okay? So that's all I need you to be able to do. And force yourself to see this. When you get to number 13, you're going to see that you have a GCF. And it is a 6. 6 fits into 18. 6 fits into a 60. That's the largest number that fits into both. So you're going to factor out a 6x, which leaves a 3x plus 10 inside. Down here, I can factor out an 8. 8 fits in. It may take you a while. You have to think what goes into a 24, what goes into a 64. You need to know some numbers. And when you sit there enough, you'll see that 8 fits into both. So I'm going to factor out an 8x. When I factor out an 8x, I'm going to have a 3x plus 8. Over here, what goes into a 24 and 64, same thing. Oh, and actually, if I would have noticed this right away, but I'm factoring, this will wipe this out, but I'm going to factor it. It's going to be another 8x and 3x plus 8. It's the same thing. So this is going to wipe out that. And if I would have known this right away, I could have crossed that out because this whole thing is exactly what I see up top, okay? Which then leaves us with a problem that a little bit harder. Now, I won't have one where you have to use the AC method, but this with some time. So if you make a box or if you do the little diamond and stuff, I'm just going to show you the factors, but realize it would take some time to get a 3x plus 10 and an x plus 7, okay? Let me just show you why this works. 3x times x is the 3x squared. Outside, I get a 21x. Inside, I get a 10x. That adds up to 31. And 10 times 7 is 70. So everything's factored correctly. And so what's left behind, once the 3x plus 10s get crossed out, I have a 6x remaining up top that wasn't canceled out and an x plus 7 on the bottom, okay? A little bit harder, and like I said, I will not have a problem where you have to use the AC method to factor, okay? Not on your quiz. Okay, last page. We're almost done. We have 2 more problems with factoring. So when we factor, you need to make sure that you're factoring everything correctly. Now, I'll save some time with 14. Just like last time, this whole thing gets wiped out by that whole thing. Okay, so I need you to be willing to see that. Okay, we could factor this, but it wipes out. Okay, it's the same thing. So we are left with a 5x plus 9, and then this I can factor out a 10. So if I remove a 10 from these 2 terms, Notice I get a 5x plus 9. Now, please be aware of this, okay? Again, star this. I warned you about this in your notes. If the numerator cancels out, and it will, this numerator gets wiped out by the exact same thing in the bottom. My answer is not a 10. I need you to realize it's 1 over 10. Huge difference. An answer between 10 and 1/10, totally different answers. 1/10 is my answer. Okay? Leaves us one last problem like this. It's a division problem. I factor out the GCF up top. So that's just a 3m. If you multiply, you're back to the original. In the bottom, I can factor out a 4. 4 fits into 12, 4 fits into a 20. So I don't have an m in common, so I can only put a 4 on the outside. 3m plus 5 inside the parentheses. Now I'm going to flip this fraction. Once again, I have this, and I'm going to factor, even though it's going to be the same thing. I could factor out a 4. You have 3m plus 5, but these will cancel out, okay? And you're left with a 3m on the bottom, okay? So the key, if it's a division problem, multiply by its reciprocal. Flip the second fraction. So now the last thing that cancels out, the 3m's disappear, and you're left with m plus 9. And we are finished with 7, like this was 7.3. So the last problem, and I decided to remove this from your quiz, but I still want it for this. I wanted to quickly review the quadratic formula. So just to review the steps to be able to do the quadratic formula, this is already in standard form. It's equal to 0. You can't factor it, but we still can solve it. So this goes back back to chapter 2. So I pick out my a, which is the number in front of x squared. My b is in front of the x. C is my constant. And I'm going to plug everything into opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, it's a 6 plus or minus square root -6 in parentheses. A lot of you are still forgetting if you square a negative, it needs to be in parentheses before you square it. Minus 4 times 6 times 7 all over 2 times 6. Okay, so all year long, I've been stressing that we must use our trusty calculator to calculate what's known as the discriminant. Don't do square root, because if you do square root, you're going to get an error. Okay, this is going to end up becoming a negative value. So -6 squared minus 4 times 6 times 7. We get -132. -132. Okay, so now we know it's imaginary. So I can write it like this. And I want you to realize this can be simplified. Let me just show you that I can divide by 4. Okay, so 4 times 33 is that 132. So I am going to rewrite this. So I'm just going to simplify it. So I just want you to realize that I want my final answer in simplest radical form. Okay, so this 6 is really going to be 6 plus or minus that root 4 becomes 2i, root 33 over 12. Now, since everything is even, I can reduce all these numbers. I can take half of. So your final answers, just so you're aware what the simplified answer would look like, it's really going to be 3 plus or minus I root 33 all over a 6. Okay, and what we did was we were able to reduce all these numbers because they had a common factor of 2. Okay, so just throwing that out at you. I want you to be aware of how we can simplify radicals, something that we did in the beginning of the year, but it's been a while, so I just want to throw that review problem in. I do not have that problem on your quiz. Okay, so that took me 35 minutes. There's a lot more problems on this practice than what's going to be on your quiz. So I'm hoping, though, you watch this and you're starting to understand the process behind all this. So thank you for watching. and you'll have your quiz next week. Take care.